So the first chemistry topic is states of matter. It's something you would have looked at back in year 9, but it's also a topic that you've seen consistently since then. And states of matter just refers to the 3 states of matter: solid, liquid, and gas. You need to know how the particles are arranged in a solid compared to a liquid, compared to a gas, and you also need to know how the particles can move. Okay, so from just drawing this diagram, and you should all be comfortable with drawing these diagrams, you can see that the particles in a solid are in a fixed position, okay, or regular pattern, and that they're all very close together. Okay, if you look at a liquid from this diagram, you can say that the particles are still close. They are all still touching each other, but instead of being in a regular pattern of neat rows, they are now randomly arranged. Still touching each other, but randomly arranged. And in a gas, you can see that the particles are really, really far apart and they're randomly arranged. Okay, in terms of movement, you need to know that in a solid, the particles can move. Okay, they do move, but they can only vibrate. So this particle here will stay in this position and just vibrate in that position. A liquid, the particles have more movement. They can move around each other. And in a gas, they can move wherever they want to. They're going to move really quickly in every single direction. Okay. Because in the gas, the particles are moving around quickly, the gas particles have the highest energy. And then on the flip side, you've got particles in a solid which can only vibrate. They are the lowest in energy. You need to know how to get from one state to another. Okay, the easiest way to remember this is just think of water because it's a common example. How do I get from a solid to a liquid? How do I get from ice to water? I would melt it. How do I get from a liquid to a gas? How do I go from liquid water to steam or water vapor? I would evaporate or I would boil it, okay? In order to melt or evaporate something, you need to put heat in. To go back the other way, to go from gas back to liquid, you're going to cool, you're going to condense. To go from a liquid back to a solid, to go from water to ice, again, you're going to cool, and it's called freezing, okay? So know your different state changes. If we look over here, we have got a heating curve. So in a heating curve, you are heating a substance. So on the y-axis, I've got temperature in degrees Celsius, and on the x-axis, I've got time. So as we are heating a substance, we need to look at what is happening to that substance. Okay, so we're going to start at looking at the temperature of that substance and how the temperature changes as you heat it. Okay, so we're starting here with our solid. And you see, as you heat it, the temperature increases. Okay, that makes sense. If you heat something, the temperature of it is going to increase. Okay, so I'm going to write on this part of the graph. That's a really thick line. I'm going to write in this part of the graph. Okay, that heating. So that's what I'm doing. It's a heating curve. Heating increases the temperature of the substance. Okay, whatever it is that I'm heating. Whatever it is I'm heating, as I heat it, the temperature of that substance increases. And you can see that on the graph by the fact that the line is increasing. Okay, and then here you've got another part of the graph that's exactly the same. And I could also write heating increases the temperature of the substance. And up here, I can see my red line is increasing. So I can say heating increases the temperature of the substance. But you will also notice on the graph that there are 2 flat parts. Okay, now I'm still heating. But for some reason, at these 2 parts here, the 2 parts where the graph flattens out, which I'm going to highlight here, these 2 parts here where the graph flattens out, the temperature of the substance stops increasing, even though I'm still heating it. Okay, and the question is why? If I'm still heating the substance, why isn't it getting hotter? Okay, it was getting hotter here, here, and here. Why isn't it getting hotter at these 2 points? Even though I'm still heating it, okay? And the reason is because at these 2 points where the graph is flat, a state change is occurring, okay? You've got a state change. Here, you're going from solid to liquid, so that state change is going to be melting. Here, you're going from liquid to gas, so that state change is going to be evaporating. But at these 2 flat parts of the graph, you have got a state change. So the question is, why does the substance stop increasing in temperature when the state is changing? And the answer is that the heat energy, actually rephrase that, the heat energy is used to separate the particles. Okay, and if we look back at our original diagram, okay, you can see that to get from a solid to a liquid, those particles need to be further apart. And to get from a liquid to a gas, those particles need to be further apart. These particles are attracted to each other. And in order to pull them further apart, you need to break those attractions, and that requires energy. To get these particles further apart, you need to break all those attractions, and that requires energy. So here, all of the heat energy was going towards increasing the temperature of the substance. But here, when it's changing state, that heat energy is used to separate the particles. Here, the heat energy goes towards increasing the temperature of the substance, and then here again, that heat energy is used to separate the particles. Once they're a gas, all of that heat energy you're putting in raises the temperature of the substance, okay? So that's what's happening in terms of heat energy, and that's why you get those two flat bits on your graph, even though you're continuously heating your substance, okay? As the state changes as well, there's a few other things you could comment on. Okay, as the state changes, the ability of the particles to move is going to change. So at this part of the graph, when the substance is a solid, okay, your particles are only vibrating. As you heat the substance, the particles are going to vibrate more and more and more. You're giving them more and more energy. And eventually, those particles will have enough energy and they'll be vibrating so much that they will be able to separate and form a liquid. And then you're heating your liquid, and those particles are moving around each other. And then as they get hotter and hotter and hotter, they're moving around each other so fast. And eventually you've got enough heat energy to actually pull those particles apart. And then you've got them as a gas where they are moving freely. Okay, so the movement of the particles is changing. The particles are moving faster and faster and faster and faster as the temperature increases. Okay, although they're getting faster and faster, while a solid, it will still only ever vibrate. As a liquid, those particles will still be touching each other and moving around each other, and it's not until they're a gas that they'll be able to move freely in any direction. Okay, so this is a heating curve. Be able to describe a heating curve and describe what is happening on a heating curve. The other thing I would recommend knowing is just being able to predict the state of a substance when they give you the melting point and the boiling point. So here it says compound X has a melting point of minus 220 degrees Celsius. So at minus 220 degrees Celsius, which is really, really cold, this substance is going to go from a solid to a liquid at minus 220 degrees Celsius. And then if you heat it up to minus 112, it's going to become a gas. So what state will the compound be at 20 degrees Celsius? Okay, well, if it was becoming a gas at minus 112, it's definitely going to be a gas at 20 degrees Celsius. Okay, so it's a gas. This one has a melting point of minus 220. Okay, so it's becoming liquid at minus 220 and a boiling point at minus 112. What state will it be at? Oh, at minus 240. So I've told you here that it doesn't become a liquid until minus 220. I'm asking you what state it's at minus 240. That's colder. That's a lower temperature than its melting point. So it's still going to be a solid. And here, what's it going to be at minus 150? Well, minus 150 is warm enough to turn it into a liquid, but it's not warm enough to turn it into a gas. So it's going to be a liquid. So make sure that you can, make sure you know your state changes. For a second, just pause the video and answer the questions that are on the screen. So I've given you elements, they're melting and they're boiling points. Just answer the questions and tell me what physical state they are. Which state will they have the most energy? And then this part here should be very, very simple. So just pause the video, answer the questions, and then press play when you're ready to see the answers. Okay, so here are the answers. They want to know at 21 degrees Celsius, okay, bromine is melting, so it's becoming a liquid at minus 7, but you'd need to heat it to 59 to make it into a gas, so it's still going to be a liquid at 21. Chlorine becomes a gas at minus 34, so it will be a gas at 21. Fluorine will be a gas at 21. Iodine won't become a liquid until 114, so you have to heat it the whole way to 114 to get it to turn into a liquid. 21 degrees is not hot enough to turn it into a liquid. It's going to be solid. Most thermal energy is gas, okay? Gas particles can move the most, they've got the most energy. And the last part here should be very straightforward. Gas, liquid, solid should be your answers. This is your heating curve again. Just pause here for a second and do these questions and press play when you're ready for the answer. Okay, so at stage B, which is the flat part of your graph, a state change is occurring, okay? They tell you it's ice, so that, and it's 0 degrees Celsius, so I can say that the state change is melting because ice melts at 0 degrees Celsius. But if you just wrote state change, that is fine. Why does it stop increasing at 23 degrees Celsius? Room temperature is 23 degrees Celsius. Okay, you take water out of the ice out of the freezer, and it's going to get hotter and hotter and hotter and hotter, and it's going to rise the whole way up to room temperature, which is 23 degrees Celsius. But that water isn't going to rise to 50 degrees Celsius if the room is only 23 degrees Celsius. Okay, so it's only ever going to get as hot as the room, and then it will stop increasing in temperature. Room temperature is typically in and around 20 to 25 degrees Celsius. Okay, so that's room temperature. That's states of matter in a nutshell. There's not a lot there. You just need to know the different states of matter, how the particles are arranged, how the particles move, and be able to interpret a heating curve. Make sure you know that the flat bits are a change of state, and make sure you know why they are flat at the change of state, because all of that heat energy is being used to separate the particles instead of being used to increase the temperature of the substance. The next bit I'm going to do in this video is separating mixtures. There's 4 different methods of separating mixtures: filtration, crystallization, simple distillation, chromatography. Okay, if I just look at the first 2, we're going to look at them together. Okay, if you were asked to separate a solid from if you had a solid, okay, in a solution, and you were asked to separate all of it out, how would you do it? Okay, we need to look at what this word solution actually means. Okay, if you've got a solution, you have got a dissolved solid in a liquid. Okay, so an example of this, you've got a solid that's not dissolving in a solution, which is a liquid with a dissolved solid. So I think the easiest thing to do is look at an example. Okay, if I had salt and water and sand all mixed in together, okay, and I wanted to get pure salt from the salt, water and sand mixture, what would I do? Okay, first things first, I want to get rid of this sand. Okay, this sand isn't dissolving and it's present as a solid. If I want to get rid of my sand, I'm going to filter it. Okay, filtration is used to remove insoluble solids. Sand isn't dissolving. I pour it through the filter. The sand is left up here. The salt and water passes through. Okay, so I've eliminated the sand. The next thing I do, okay, to separate the salt and the water is I would use crystallization. Okay, that salt is dissolved in the water. I'm going to use crystallization. So I'm going to put my salt and water in my evaporating dish. I'm going to heat it. All of that water vapor is just going to evaporate. And when it evaporates, I'm just left with my salt. Okay, so you have got a solid and a solution. To separate the salt out, you first need to remove your insoluble solid. You're going to use filtration. Then you're going to use crystallization, heat the water, evaporate it. You're just left with your salt. Another method, simple distillation. Okay, so if we look here at our crystallization, and I had salt and water. When I do crystallization, I evaporate the water, but I lose the water. Okay, it just evaporates off into the atmosphere, and I'm left with no water. That's not a problem if your aim is to isolate salt, but just say your aim is to isolate the water, okay? Just say you want to drink this water and it's really salty and you're trying to purify it, okay? Just say you're trying to purify salt water so that you can drink it, okay? You need to separate the salt and the water, but you need the water to be left over at the end so that you can actually drink it. If you use crystallization, you're going to lose all of the water. It's just going to evaporate off into the atmosphere and you're going to be left with salt, okay? That's not going to help you when you're thirsty. So a different technique is simple distillation. And what you can do with simple distillation is here you've got the salt and the water, okay? And again, you're going to heat it just like we did before. And again, when you heat the salt and water, your water is going to evaporate and it's going to form water vapor. But instead of that water vapor being able to escape like it was up here, that water vapor is now all going to become trapped, okay? It's going to become trapped in this condenser. And this condenser has got cold water. You can see it here, cooling water in, cooling water out. That condenser has got cold water flowing all around it. So when your hot water vapor rises up here into the condenser, it's going to cool down immediately, and then it's going to condense and turn back into a liquid, and you can collect it. Okay, so here you are heating, and the water goes from a liquid to a gas. That hot water vapor rises, it gets trapped in the condenser where it is cooled down, and when it is cooled down, the water is going to go from a gas back to a liquid. You can then collect that liquid here, and it will be pure water that you will be able to drink, and all of the salt will be left behind in your distillation flask. This is called simple distillation, and it's a method of separating salt and water that enables you to keep the water instead of losing the water like you would in crystallization. Okay, you can also use simple distillation for separating a mixture of liquids that have different boiling points. Okay, so for example, if you had alcohol and water mixed together and you wanted to separate them, alcohol boils at 78 degrees Celsius, but water boils at 100 degrees Celsius. If you had a mixture of both of them here in your flask and you started to heat, okay, as soon as it hits 78 degrees Celsius, that alcohol is going to turn into a gas, and it's going to rise up into the condenser where it will cool, condense, and be collected. As long as you keep an eye on your thermometer and you make sure that you don't go to 100 degrees Celsius, your water will stay behind in the flask. So you heat it enough to turn your alcohol into a vapor, which you can then cool, condense, and collect. But you don't heat to 100 degrees Celsius because you want the water to stay as a liquid in your flask. Okay, so that is distillation. It can use to separate mixtures of liquids with different boiling points, or to separate a soluble solid from a liquid, enabling you to keep that liquid. Okay, I would recommend doing. If you look at a question here on distillation, if you just press pause for a moment, do the questions, and then press play when you're ready for the answer. All right, so if you look at the answers, what temperature would the thermometer show? Okay, in this case, you are trying to purify water. You're going to heat it to 100 degrees Celsius because you want the water to evaporate so that it can cool, condense, and be collected. You want all of those impurities like salts to be left behind in the flask. So you're going to heat it to 100 degrees Celsius. The piece of apparatus labeled OR is called a condenser, and you use it to cool and condense the water. Okay, the condenser, I'll just highlight it. The condenser is all this bit here on the very outside of the tube. And what it does is it keeps that inner tube really, really cold. Without the condenser, the tube is not going to be very cold, and it will be harder for you to cool and condense your hot water vapor. So by having this condenser around the tube, it keeps everything super cold. It enables you to cool and condense the water and makes the process a lot more efficient. And this whole process is called distillation. That's pretty much it in a nutshell for CC1 and CC2. Any questions about any of it, just let me know.